Boys and girls, I'd like to make a suggestion to you. As you work through this video and the corresponding worksheet, what you should do is, at least after we get the first polyhedron taken care of, I'd like for you to pause after I introduce the new polyhedron, and I'd like for you to try to figure out the number of faces, edges, and vertices that each of these polyhedrons has, as well as sketch your own net and find the surface area. And then play the video and check to see if your work matches mine. Okay, give it a try. Hello boys and girls, today we're going to start Unit 10, Surface Area and Volume. And to kick things off, we need to talk about 3D shapes. Now, more specifically, not just any 3D shapes, we're going to talk about polyhedrons. For example, what we would call here this box, this is actually a polyhedron. More specifically, it is a rectangular prism. And there's some key vocab that we need to get associated with. First of all, this thing up front here, okay, there's a front, there's a back, there's a top, there's a bottom, there's a right, and there's a left. Okay, these are not sides. They're faces, okay? When we talk about sides, that's a line, okay? And usually we're talking about just a two-dimensional shape. But these are faces. They're surfaces of a polyhedron, okay? So first of all, we've got to get that taken care of. These are called faces. And then we also have edges. Where two faces come and meet together, that is an edge. Okay, that's an edge right there. There's another edge. See the top face and the front face, they intersect right here, and that forms an edge. And last but not least, we also need to call these corners here actually vertices. So if you hear a vertice, that's where three or more faces intersect at one point, and that corner is called a vertice. Let's take a look at some specific polyhedrons, and we're also, I almost forgot the good part, we're going to talk about nets too. Boys and girls, let's look at our first shape. Now our first shape, 3D shape, polyhedron, is actually a triangular prism. Now this triangular prism has 1, 2, 3, 4, 5 faces. Okay, 5 faces, and it has 1, 2, 3, 4, 5, 6, 7, 8, and 9 edges. 9 edges. Okay, and let's not forget about the vertices. It also has 1, 2, 3, flip it over, 4, 5, 6 vertices. Okay, this is a triangular prism. Okay, a neat thing about triangular prisms is it's called a triangular prism. It gets its first name, triangle, because that's the base shape. Okay, the base polygon is a triangle. And then all of the remaining faces that connect the top face and the bottom face, which are triangles, are all rectangles. And that's common of all prisms. Okay, you have the first name of the prism is its base shape. Okay, and then the rest of the surfaces, okay, are all rectangles that connect the top base and the bottom base, which are the same. And if we were to, we're going to talk about net now. If I were to peel all of the surfaces off of this polyhedron here, this triangular prism, it would end up looking like this. I don't know if you can see this. Okay, see, I took this object and I peeled off all of the faces. I peeled off all of the faces that go around, as well as the top face and the bottom face, and this is what we're left with. This is the net. Okay, and I could take this and fold it back up again, fold it back up, and make an identical triangular prism just like this one. Let's see if we can create our own net from a triangular prism and then find the surface area. Okay, boys and girls, as stated earlier in the video, the number of faces that a triangular prism has is 5. It has a front and back triangular face. It's also the base shapes. And then it will have 3 rectangular sides, and in this case they're all squares. A triangular prism will have 9 edges and will always have 6 vertices. Now we want to find the surface area. And how do we do that? We need to take our three-dimensional object and transfer it into a net. Now what we're doing is we're just peeling all of the faces back. It's kind of like unfolding this triangular prism, and then we flatten it out, and now we have an irregular polygon. And we know how to find the area of irregular polygons. But first, let's get our dimensions. It says that the dimensions of the triangular face, the base is 6, and the height of the triangular face is 5 units, whatever units they are. And then all of the sides of the rectangles are 6, which makes it a square. Okay, so let's transfer that data to our net. That means that each of these square faces is 6 by 6, which would give us 36 square units. And then our two triangular faces have a height of 5, and we know that area is equal to base times height divided by 2 for a triangle. And our base is 6, our height is 5, which gives us 30. We divide it by 2, and that gives us 15. So now we have the area. And this triangular face is identical to the other one. All of these faces happen to be identical as well. And we're not done yet. The last step then is to find if we want to find the total surface area, we need to total all of the surfaces. So we've got a 36, a 36, a 36 units squared for each of the rectangular sides. And then we have two triangular faces. And when we add that all up, we have 138 units squared. And that's all. Polyhedron number 2. We now have a rectangular prism. It's called a rectangular prism. Its first name comes from its base, which is a rectangle. Some of you might be saying that's a square. Well, a square is a rectangle. And which rectangle do we know? It's all rectangles, okay? Rectangular prisms are really easy to identify. All of the faces are rectangles. Okay, but let's take a look and see how many faces it has. It has one top face, bottom face, that's 2. It's got a front and a back, that's 4. Right and a left, that's 6. So it has 6 faces. How many edges does it have? Well, it's got 1, 2, 3, 4. And then it's got 1, 2, 3, 4. And don't forget about the connectors. 1, 2, 3, and 4, which is a grand total of 12 edges. Now, how many vertices does it have? These sharp and pointy things. Okay, it's got 1, 2, 3, 4 up there, 1, 2, 3, 4 down there. Altogether, it has 8 vertices. And when we unpeel it or flatten it out, we end up with an irregular shaped polygon like this, which is actually a series of polygons. We can see here is our base polygon. Here is the opposite base polygon, and then the rest are rectangles that wrap around and the top over here. Okay, so this is what our net would look like. Okay, that's it. Let's see if we can find the surface area of the net. Boys and girls, let's look at our next polyhedron. We have a rectangular prism, and a rectangular prism will always have 6 faces, 12 edges. 12 edges, that's correct, and a grand total of 8 vertices. Now to find the surface area, once again, we need to take our polyhedron and unpeel it, unfold it, flatten it out into all of the polygons that make up the outside surfaces, all the faces of this 3D shape. And the dimensions that were given to us, this is a 6 by 6 by 10 rectangular prism. So what does that look like? That means that our base rectangles here are 6 by 6, which we know are 36, and 36 units squared. Okay, and these rectangles here are going to be 6 by 10, and we have 4 of them. And we know that 6 by 10 is 60, 60, 60, and another 6 by 10 gives us 60. So we have 4 rectangles with the area of 60 units squared, and then we have our 2 base shapes, which are squares. And when we add all these areas up, we come to a grand total of 312 units squared. 312 units squared. Okay, let's look at the next problem. Moving right along, we have another polyhedron. Oh, I feel like I'm in Egypt. This is a square pyramid. I know what you're all thinking. It doesn't look square to me. Well, look at the base. Ooh, the base is a square. And once again, that's where these polyhedrons get their first name from, whatever the base shape is. And the base shape happens to be a square. And what's true and common of all pyramids is the faces that come up from the base that form a point at the top are triangles. That's what makes it a pyramid. Okay? And a pyramid, what's interesting about a pyramid too is it only has one base. Okay? It's base shape down here, and then the top is a vertice. Okay? The pinnacle. Okay? And let's count up the faces. We've got a bottom face, and we have 1, 2, 3, 4. 4 faces coming up from each side or edge of our square, which gives us a grand total of 5 faces. How many edges does it have? Well, it's got 1, 2, 3, 4 that go along the edge of the base, and then there's 4 coming up. 1, 2, 3, 4, which gives us a grand total of 8 edges. Now, how many vertices? Well, we got 1, 2, 3, 4, and the one on top, that's 5. The interesting thing about pyramids is the number of faces that they have will also correspond with the number of vertices. Okay, just keep that in mind. And when we unpeel this guy, look what we get. We get a flower or a star. I'm not quite sure what it is, but I like to think of it as a flower, okay? What we did is we unpeeled it. This is the base, and then we folded back all of the faces, and we get this shaped net. Very interesting looking. Okay, let's see if we can find the surface area of this guy. Boys and girls, let's look at our next 3D shape. This polyhedron is a square pyramid. It's called a square pyramid because the base is a square, and then all of the faces that go up from this square to this pinnacle here, this special vertice, they're all triangles. Okay, so the number of faces would be 5 for a square pyramid. All square pyramids will have 5 faces. All square pyramids will have 8 edges. And all square pyramids will also have 5 vertices. The neat thing about pyramids is they'll always have the same number of faces as vertices. Now, to find the surface area, we need to flatten this pyramid out. We need to unpeel it, unfold the skin, all of the faces off of it, and you can kind of use the square base as kind of the center of the flower, and then just you're peeling back all the petals. The dimensions for this square pyramid, we know that the square base, it's going to be 6 by 6. So all of the, it's a 6 by 6 square. And then the height of each triangle, and all of these triangular faces are going to be the same, have a height of 5. Okay. So let's, first of all, if this is a 6 by 6 square, which it is, once again, the area is going to be 36. And if the height of each of these triangles is 5, we know that the area of a triangle is base times height divided by 2. Our base is 6, our height is 5, 6 times 5 is 30, divided by 2 is 15. So each of these triangular faces will be 15 square units. And see, that's surface area. We're just totaling up all of the faces, all the surfaces of our 3D shape, of our polyhedron. And we would have one base, that's 36. And then all of the faces, all 4 faces that come up from each edge of the square, they're all 15. And when we total this up, we're going to have 96 units squared. 96 units squared. Finally, polyhedron number 4. And this polyhedron is a pyramid, but what kind of pyramid is it? Well, let's look at the base. It's a triangle. So this is a triangular pyramid. And a triangular pyramid will have 1, 2, 3, 4 faces, okay? Because we have our base down here, and then from each of the edges, a triangle will also come up and it will form a point at the top. And that point is a vertice. Okay, so we have 4 faces. We've got 1, 2, 3 edges there, and then we've got 1, 2, 3 edges coming up for a grand total of 6 edges. And how many vertices does it have? Well, if you remember what I said last time, the number of vertices for a pyramid should also match the number of faces. And if we have 4 faces, we should have 4 vertices, but let's count. We've got, okay, let's see if we can center this. We got 1, 2, 3, 4. Sure enough, we do. Okay, I dropped that. And if we were to unfold this and flatten it out, this is what the net would look like. It would look just like this. We can see this is the base, and then here are the 3 sides that fold up to form a pyramid. Let's see if we can find the surface area of this net. Okay, boys and girls, we have a triangular pyramid. Last and least, at least as far as surface area for this 3D shape, this polyhedron, we already stated that this triangular pyramid, as well as all triangular pyramids, will have 4 faces, 6 edges, and 4 vertices. Once again, the number of faces and vertices for all pyramids will always be the same. Okay, whether we have a square pyramid or a triangular pyramid or even an octagonal pyramid, the number of faces will be equal to the number of vertices. Okay, now this is an interesting triangular pyramid. All of the sides of, and I did say sides, all the sides of each triangle will be 6. So we have an equilateral triangle, and the height from the base to this vertice up here, the height is 5. So if we find the area of one triangle, we find the area of all of the triangles. We know that our area formula for a triangle is base times height divided by 2, which is 6 times 5 divided by 2, which is 15 units squared. So we have 15 units there, 15 units there, 15 units there, and 15 square units there. We can just say, hey, we got 15 times 4, we know is 60 units squared. So there is our answer. I hope that this was fun. Boys and girls of Wake County, it's that time to say goodbye. I hope that this was informative. I hope I also answered all your questions about polyhedrons and nets, and I hope that you have a new sense of confidence as you try to find the surface area of polyhedrons. Until next time, goodbye.